Space, the final frontier. We dream of humans on Mars, of bustling lunar outposts. But before we pack our bags for the cosmos, there's a more down-to-earth matter to consider: food. It's not as simple as tossing some protein bars in a rocket. We're talking about sustaining human life in a hostile environment, hundreds of thousands of miles from the nearest supermarket. Imagine this. You're an astronaut, gazing out at the red dust of Mars. You're hungry. What's for dinner? A freeze-dried pouch of something resembling beef stew? Or perhaps a few leaves of lettuce, painstakingly grown in a Martian greenhouse? We need to crack the code of sustainable food and water sources in space. Think about the logistics. Every pound of food launched into space is a pound that adds to the weight of the spacecraft, requiring more fuel and increasing the cost of the mission. The challenges of feeding astronauts in space are numerous. First and foremost, there's the issue of weight and storage. Food needs to be lightweight, compact, and shelf-stable for months, if not years. Second, we have the challenge of nutrition. Astronauts need a balanced diet to maintain their health and performance in the demanding conditions of space. Think about the effects of microgravity on bone density and muscle mass. We need food that can combat these effects. And let's not forget the psychological aspect. Food is about more than just sustenance. It's about culture, comfort, and familiarity. These are not just logistical hurdles, but human ones. The good news is that we're not starting from scratch. Decades of space exploration have spurred innovative solutions for feeding astronauts. We've gone from the bite-sized cubes and freeze-dried powders of the early space race to more palatable and nutritious options. Today, astronauts enjoy a wider variety of pre-packaged meals, including irradiated foods that can last for years without refrigeration. We've also made strides in developing space farming techniques, allowing astronauts to supplement their diets with fresh produce. Imagine the joy of biting into a crisp lettuce leaf grown on the International Space Station. As we venture further into space and contemplate longer missions, we need to think beyond pre-packaged meals and space gardens. We need to develop truly sustainable food systems that can support human life in the cosmos. Water, water everywhere, but not a drop to drink. That's the conundrum of space. We've discovered ice on the Moon and Mars, tantalizing hints of potential water sources. But extracting, purifying, and utilizing this extraterrestrial H2O is a challenge we're only beginning to address. Every drop of water an astronaut drinks, every bit used for hygiene or growing food, has to be accounted for. The current system relies heavily on water recycling, a process that turns sweat and urine into drinkable water. Long-duration missions, however, will demand more sustainable solutions. We can't rely solely on Earth-launched supplies, especially as we venture further from home. Finding ways to locate, extract, and purify water on other celestial bodies isn't just a scientific challenge, it's a necessity for the future of human space exploration. Zero G, zero nutrition? Space is a tough environment. It's not just the lack of gravity that plays havoc with the human body. Radiation exposure, the psychological stress of confinement, and even the unique lighting conditions can impact nutrient absorption and overall health. Astronauts often experience bone density loss and muscle atrophy in the microgravity of space. Despite rigorous exercise routines, their bodies simply aren't subjected to the same gravitational forces as on Earth. Many astronauts report a decreased appetite in space, possibly due to changes in hormone levels or the unusual eating experience in microgravity. The challenge is to create food that not only provides balanced nutrition, but also counters the physiological effects of space travel. Space food, from farm to fork, in orbit. The future of space food isn't just about sustenance, it's about creating a closed-loop system. Think self-sufficient space farms that provide fresh, nutritious food for astronauts, reducing reliance on Earth-based supplies. Hydroponics and aeroponics, methods of growing plants without soil, are already being tested on the ISS. These systems use less water and space than traditional farming and can be tailored to grow a variety of crops. This isn't science fiction, it's the future of space exploration. Space Farming 101, Sowing Seeds in Microgravity. Remember those science fiction movies with sprawling hydroponic gardens on spaceships? Turns out they weren't too far off. Space farming is no longer a futuristic fantasy. It's a scientific reality, and it's playing a crucial role in tackling the challenges of feeding astronauts. The veggie experiment on the ISS, for example, has successfully grown a variety of leafy greens, proving that we can cultivate fresh produce in the challenging conditions of space. But space farming isn't as simple as planting seeds in lunar soil. To overcome these hurdles, scientists are developing innovative hydroponic and aeroponic systems that deliver water and nutrients directly to plant roots, mimicking the effects of gravity and optimizing growth in a weightless environment. From waste to taste, the art of space recycling. In space, nothing goes to waste, literally. Every drop of water, every ounce of air, even astronaut waste is meticulously recycled and repurposed. It's a closed-loop system driven by necessity and fueled by ingenuity. Remember the water recycling system mentioned earlier? It's a critical piece of this puzzle. The process involves collecting and treating wastewater, including urine, to remove impurities and make it safe for drinking. Scientists are exploring ways to compost organic waste and use it to fertilize plants, creating a self-sustaining food loop. These recycling technologies are not only essential for long-duration space missions, they also offer valuable lessons for sustainable living on Earth. Beyond freeze-dried cooking up a space-age menu, gone are the days of bland, freeze-dried meals and flavorless tubes. While these options served their purpose in the early days of space travel, the future of space food is all about variety, taste, and nutrition. Imagine astronauts enjoying gourmet meals prepared with fresh ingredients grown on board their spacecraft, or indulging in personalized menus tailored to their dietary needs and preferences. 3D food printing is emerging as a game changer in this realm. Imagine a printer that can create customized meals on demand, using a variety of ingredients and textures. These advancements aren't just about satisfying astronauts' taste buds, they're about maintaining morale and psychological well-being during long-duration missions. After all, good food is good for the soul, even in space. Farming in the sky, hydroponics, and beyond. Picture this: a spaceship hurtling through the vast emptiness of space, its interior bathed in the soft glow of LED lights. But instead of sterile, metallic walls, imagine lush, vertical gardens lining the spacecraft, their leaves a vibrant green against the backdrop of the cosmos. This is the promise of hydroponics and aeroponics, technologies that are poised to revolutionize food production in space. Hydroponics, the art of growing plants without soil, using nutrient-rich water solutions, has already taken root on the International Space Station. Aeroponics takes this concept a step further, suspending plant roots in the air and misting them with a nutrient-rich solution. This method requires even less water and space than hydroponics, making it ideal for the constraints of spacecraft and future off-world settlements. Scientists are exploring ways to grow a wider variety of crops in space, from dwarf fruit trees to protein-rich legumes, using a combination of hydroponics, aeroponics, and even artificial intelligence to optimize growth conditions and maximize yields in these controlled environments. Section 2, Space Cuisine 2.0, From Printed Food to Martian Greenhouses. Remember the days of freeze-dried ice cream and tubes of pureed food? Those relics of early space travel are slowly giving way to a new era of space cuisine, one that prioritizes variety, flavor, and even the psychological well-being of astronauts on long-duration missions. Imagine a future where astronauts gather around a table, not to rehydrate their meals, but to share freshly baked bread made from wheat grown in a Martian greenhouse, topped with tomatoes and herbs harvested from a hydroponic garden. 3D food printing is another exciting frontier in space cuisine. This technology, already being explored on Earth, could allow astronauts to create customized meals on demand using a variety of ingredients, textures, and flavors. Beyond the technical advancements, there's a growing recognition of the importance of food in maintaining morale and fostering a sense of normalcy in the challenging environment of space. Section 3. The Quest for Cosmic Water, Turning Science Fiction into Reality. Water, the elixir of life, is a precious commodity in space. Every drop consumed, every liter used for hygiene or plant cultivation has to be carefully managed and recycled. But as we venture further into the cosmos, relying solely on Earth-launched supplies becomes increasingly impractical. The good news is that water isn't as rare as we once thought. Scientists have discovered vast reserves of ice on the Moon and Mars, potential gold mines for future space explorers. The challenge now lies in developing efficient and sustainable methods to extract, purify, and utilize this extraterrestrial water. These advancements in water extraction technology, combined with ongoing research into advanced water recycling systems, offer hope for a future where space travelers can access this vital resource not just for survival, but for thriving in the cosmos. Section 1. The global quest for space sustenance. Feeding astronauts on a journey to Mars isn't a one-nation job, it's a global effort, a testament to the unifying power of space exploration. Scientists, engineers, and nutritionists from around the world are pooling their expertise to crack the code of sustainable food systems for space. International collaboration is key. The European Space Agency, for example, is developing the MELISA, the Micro-Ecological Life Support System Alternative, a closed-loop life support system that aims to recycle waste and generate oxygen, water, and even food within a spacecraft or planetary habitat. By sharing knowledge, resources, and expertise, we can overcome the challenges and pave the way for a future where humans can thrive beyond Earth. Section 2. Simulating Space Earth's testing grounds. Before we send astronauts on a year-long journey to Mars, we need to ensure they have a reliable food supply. That's where Earth-based simulations come in, offering a controlled environment to test and refine space farming techniques before sending them into orbit. In the Arizona desert, the Biosphere 2 project serves as a giant test tube for closed-loop life support systems. This massive sealed structure houses a variety of biomes, from a rainforest to an ocean, allowing scientists to study how humans interact with and depend on their environment. These Earth-based simulations provide invaluable data, helping us optimize growing conditions, select the most suitable crops, and develop resilient food production systems that can withstand the rigors of space travel. The future of food in space is as boundless as the cosmos itself. As we continue to push the boundaries of exploration, we'll encounter new challenges and discover innovative solutions that could revolutionize not just space travel, but also life on Earth. Imagine a future where space farms orbit Earth, beaming down fresh produce to a hungry planet. Or picture self-sufficient lunar outposts, their inhabitants enjoying meals made with ingredients grown in lunar greenhouses. The knowledge gained from developing sustainable food systems for space could have profound implications for addressing food security issues here on Earth. The journey to space is, in many ways, a journey to understand ourselves and our place in the universe. Our journey into the cosmos is about more than just reaching new destinations. It's about expanding our understanding of what it means to be human, to live, and to thrive beyond the confines of our home planet. At the heart of this endeavor lies a fundamental need to nourish our bodies and souls. We've come a long way from the days of bite-sized cubes and freeze-dried powders. Space food is no longer just about sustenance. It's about creating a sense of normalcy and comfort. Imagine astronauts on a long-duration mission, gathering for a meal prepared with fresh ingredients grown on board, sharing stories and laughter as they gaze out at the stars. This vision of astronauts thriving, not just surviving in space, is within our grasp. The quest to feed astronauts in space isn't just about exploration, it's about innovation, with the potential to revolutionize food production on Earth. Technologies like vertical farming and water recycling hold promise for addressing our planet's challenges. Imagine adapting space farming techniques to urban environments, reducing transportation costs, and providing fresh produce. Picture using closed-loop recycling systems to conserve water in drought-stricken regions, applying our understanding of plant biology to develop more resilient crops. The knowledge from space exploration filters back to Earth, improving our lives. The quest for sustainable food systems in space could help create a more food-secure and sustainable future. The future of food in space is a story still being written, a culinary adventure with chapters yet to unfold. As we push the boundaries of human exploration, the need for sustainable, self-sufficient food systems will only become more critical. Imagine astronauts dining on fresh vegetables grown in Martian greenhouses, their meals supplemented by 3D printed protein bars. Picture lunar colonists sipping on water extracted from moon ice, toasting with wine made from lunar grapes. These scenarios, once science fiction, are now within reach. The quest to feed humans in space is driving innovation, pushing the boundaries of what we thought possible, offering a glimpse into a future where humans thrive beyond Earth. So as we explore the cosmos, let us do so with wonder, collaboration, and a commitment to sustainability. For in nourishing our bodies in space, we may discover the key to nourishing our planet and securing a brighter future for all.